Hello, today I've got something a little bit different. It's not a synthesizer and it has no keyboard. But this is a gsp-5 from Digitech, and it's a guitar processor, effects unit and preamplifier as well. It has things like reverb, chorus, flange, delay 1, delay 2, multi-tap, distortion, amp voicing and EQ. And there's also a sort of MIDI in and MIDI through, which I guess is what you use to control some of the parameters when this is in a rack unit that you can't reach. But like I say, I don't really know a lot about this type of gear, but electronics is electronics. So I said I would have a look at it. It belongs to a friend of mine who said the last time he plugged it in, it started to smell of burning, a little bit of smoke and things. So I'm going to open it up and try and see if there's anything obvious that's died in this thing. So let's open it up and see if we can spot what the problem is, shall we? Very neat, very nice. Okay, so I can sort of smell that there's been a bit of a burning session going off in here somewhere. So now I've got to look for the obvious component that's burning. And the first thing to check, obviously, is the transformer. And that looks okay. Now, I did say it was still lit up, and the thing still lights up and does something. So that transformer looks fine, really. There's a little fuse in here, I guess. It's a strange place to put a fuse. Mind you, the fuse is going to be okay because it's, like I say, it's lit up. It works. So the next obvious things to look for is the capacitors. I mean, this is where the power is coming in here. So all these capacitors are sort of next in line, and they look okay. There's no capacitors bulging. You can normally tell when capacitors are on the way out because the tops will start to bulge, or even the bottom where the sort of rubber coating is. Sometimes that will bulge and you'll have some of the electrolyte starting to leak out of the capacitor. Under here, I'm guessing by the looks of these legs, are the power regulators. So what have we got here? LM340, 7812, that's a 12 volt positive regulator, and 7912, that's a 12 volt negative regulator. Now, if the number begins with 78, it's always a positive regulator, and 79 is always a negative. And then the two numbers that come after that, so this is 7812, those two figures, 1, 2, makes it 12 volt. So if it was a 5 volt regulator, it'd say 7805. But, I mean, they look fine. Sometimes when these go, you will get a sort of a little bubble or a little tiny hole develop in the black plastic, and that's where the thing has been smoking through. So for the moment, I'd say they look okay. So, I mean, I'm not going to power this thing up yet, because if he switched it off in time when a component started smoking, then we might be able to save this. But if I go and turn it back on right now and the component carries on burning and then eventually destroys another component next to it, then we're going to be in trouble. Let's just have a look around while we're here. A VLSI chip, Digitech. Now, these are digital effects processor chips, and you find these in the Kurzweil, or is it Kurzweil? I can never pronounce that right, I don't know. They're in the K2000s and the K2000R. I think the K2000 has 3 of these in there. And they're really expensive to try and source these now. So that chip alone is probably worth a few quid. Here you can see the TMS 4464. They're basically just DRAM. I think the 64K DRAM memory they are. Oh, a Burr Brown. Now, Burr Brown joined forces with Texas Instruments. So Burr Brown and Texas Instruments is the same company now. And this is a PCM 54HP. So that is the digital to analog converter. I think they don't produce that anymore. They've replaced it with a DAX 7742 or something, which isn't quite 100% equivalent, but right next to it here, oh, hello. That looks like a burnt component there. That's a tantalum capacitor, and that certainly looks like it has been smoking. I'll just get the camera in for a bit of a close-up. Oh, that's lucky. That would have taken me ages to find that if I just sort of started searching across the board. But that's definitely a burning component. Let me just get the camera in a bit closer. There is a tantalum capacitor. And next to it is what the tantalum capacitors should look like. And if you can see there, it's definitely got a burn spot where smoke has excavated itself through the side there and made a little hole. So yes, that is definitely a dead component. But what made that fail? So what I'll do, I'll take off the circuit board and I'll take that out and I'll do a few checks of the components around it and the components that lead up to that. Because it's not necessarily that is the problem. It could be something else that has failed, that has caused this to fail. But hopefully, I don't know, I think I'll just have a look, see if I can replace that and then maybe power it up and see what happens. Right, I've taken off every single screw because I just can't seem to get this bloody thing out, and I can't see any more screws anywhere, so that has got to be it. Now come on, yeah, that's what I want. Thank you very much. So there's our obviously dodgy tantalum capacitor there, and to figure out exactly where it is, I'm going to count down the legs of this chip. 1, 2, 3, 4, 5, 6 and 7. So it's in line with number 6 and number 7, and there's another capacitor there, so it's the second row out opposite 6 and 7. So count it back this way. 1, 2, 3, 4, 5, 6 and 7, and that's the second one out, so there it is. So if I just mark that, at least I know which bit to solder. It's very close to a lot of other components. Should be able to get that out. Let's see if this is successful. If not, because it's dead, I can always sort of chop it out and wrench it out, and then just desolder the 2 pins that will be left over. But I need to find out what value that tantalum capacitor is. And I think it may have actually burnt off the information, which is a bit of a shame. Can't really do guesswork with replacing capacitors. I've taken out these 3 chips around here just to try and give me a little bit more space, because there's not a lot of room to work in there. So now I want to find something to clip onto those. No, that won't do. Let's try this. Yeah, that might do. And just get those capacitors out. Right. I think we can see what was marked on this. Oh, that's good. Okay, it's 10 microfarads at 16 volts, tantalum. However, what about the one next to it? Is that one okay as well? Because that looks a little bit brown. It might be a good idea to actually replace the both of them. They look the same. And it looks to be where it was going on to this chip here. It looks to me there was something to do with the plus 12 and minus 12 voltage coming in, possibly because of the pins where it was going in there. So I'll just check that on the capacitance meter anyway. See what it reads. No capacitance at all, just a resistance of 4 ohms. Double check. No. Oh dear. Should say 10 microfarads at least. I don't really like using the tantalums. They've never really been a very successful capacitor. Okay. Right, the tantalum capacitor is a problematic capacitor in many repairs that we've had to do in the past. What have we got? So we've got 10 microfarads at 16 volts. So if we stick to 10 microfarads, it doesn't matter if the voltage is a little bit higher. That's just what it will sort of handle. It's safety margin. So 10 microfarads. What have we got here? 47 microfarads. Nope. Okay. I mean, you could really get away with putting electrolytics in, I guess, because I think that's just to do with smoothing out ripple for the power that's going into the DA converter. Or is it an AD converter? No, it's a DA converter, I think. Right, got some tantalums in here. Let's have a look at these, shall we? 10 microfarads at 16 volts. Thank you very much. And 10 microfarads at 16 volts. There we go. We have a pair. So I could change both of them and just put a couple of new ones in. And that may keep the unit working for a few more years before it decides to die again. Or it might just fix it for good. Who knows? Now, I'm just going to recheck these on the capacitance meter to make sure they're absolutely okay. I mean, I know they're new, but new as in they've been in this drawer for years and years. So let's just check those out. See what happens. Haha, 10 microfarads. Lovely, thank you very much. That's one good one. Try this one. $10 microfarads. There you go. We've found the replacements. So I'm going to take that other one and replace both of them. Now, you must remember that these tantalum capacitors, they're a bit like the electrolytics. They have to be put in the right way around. So I did take note of which way around that came out, but on the board, fortunately, it does give you a little plus symbol. Just down there, don't know if you can see that, little plus symbol, so you can sort of figure out which way around it goes. Right, okay, let's get that out. Alright, I've just got one awkward little hole just there that I can't quite undo. Come on. Yeah, that'll do. I know they're sitting off the board a little bit, but it doesn't matter. It just makes it easier for me to it makes it easier for me to remove them again if I have to pull them out. Positive. So that's the other way around. Okay. And then just check that you haven't soldered across any tracks. So, okay, they're sitting a little bit high off the board, but there's plenty of room for them. And that way I can do a temperature check on them when I power the thing back up. And hopefully, if it works, I mean, I don't know if it's going to. But that's my guess as to what the problem is there. So now I'll put these chips back in. If you ever take microchips out of the sockets and replace them back in, you'll notice there's always a little indentation. So we've got a little indentation there, there's a little indentation there, and that tells you which way round the chip has to go in, because it has a little sort of notch at one end. It'll either have a little notch or it'll have a little circle next to pin number 1, and that tells you which way round the chip has to go. These little op amps may have been damaged as well while this has been cooking. So I'm going to power it up and see what happens first, and hopefully it hasn't damaged the op amps or the DA converter or AD converter. I can't remember what that is. Now this is what I would call bad design here. If you take off this connector to repair the board, you've got to sort of remember which way round that connector went. Now this is a keyed connector. It's got the little plastic slots down one side of it. So normally you would have a connector that would have a little stop piece on it, so you can't put it on the other way round. Or at least you would have some sort of symbol printed here to show you which way round it goes. And I've just had to rewind some of the videotape to figure out that it was this way around. And I just think that's not really a very good design, that, because you could put that in the wrong way round and just completely blow the entire thing if you didn't take notice of which way round you undid it. So that's just a little niggle. Anyway, this is all together in the box now, and I'm going to power it up and see what happens. Right, for safety now, before I switch this on, I'm going to put my little goggles on here, because not so much tantalums, but if the electrolytic capacitors explode, you get little shards of aluminium flying around at high speed, and you know, I quite like my eyesight as it is. So a little bit of safety there, and then plug in, and I'm going to use the heat camera here and see how quickly these things heat up. See if they just want to burn out instantly again. Right, okay. What I should really do is put one of the screws in. Put one of the screws in here, this back plate, because the earth is connected to this back plate and this is connected to nothing. So if I just stick one of the screws in here for the moment, that'll earth the chassis again. And now, because the earth is bolted to there and this is screwed, everything's earthed again as it should be. Right, okay, let's try this. Let's wait for the fireworks and see what happens. Fingers crossed. Here goes. Turn on. Oh, and it says battery on the front. Oh. All the chips are warming up, but those capacitors aren't warming up. No, it looks fine through here. Right, well, let me show you what's happening on the front here. Now that flashing is due to the camera. That's not seen by the human eye, it just looks static because the camera is working faster than your human eye can work. So that looks like it's flashing away, but believe me, it isn't flashing away to my eyesight. But whatever it's doing, all right, yeah, okay, it's doing something now. So I think we should send a signal into it at least, and hear what comes out of the other end. So this has been on for 1 hour now, and I've rechecked the temperatures and things, and everything's at the same temperature as it was in the first couple of minutes of switching it on, and the capacitors seem to be fine now. The only problem is I don't even know how to use this guitar processor preamp thing. I really haven't got a clue, because I'm not a guitarist. But from what I can gather, I think it's doing possibly what it's supposed to be doing. It does say distortion. It sounds like an electric guitar. So half the problem with electronics, repairing things like this is, okay, you can fix something with a couple of components that probably cost 50 pence or £1. But it's the amount of hours that you sometimes have to put into actually finding what the fault is. Now, I was really lucky there because I was just blabbering on about the chip numbers and telling you what the chips were doing, and just instantly fell on to the fact that there was a capacitor that was very brown, the wrong colour, obviously burnt. So I was very lucky to have sort of dropped onto that nice and quickly. But in reality, that could have taken hours to actually have found that piece that was gone wrong with it. But capacitors, they very commonly come up in a lot of electronic repairs of old vintage gear, old synthesizers and all sorts of things. It's very common that capacitors need replacing. So if you are going to have a go at repairing something yourself of a particular vintage, always have a look at the capacitors. Always check if the electrolytic capacitors are domed on the top, or if there's any electrolyte leaking from underneath, or if there's any that look like they're burnt. Or if in doubt, if you can afford to, just change them. Anyway, I hope that's been useful to you, and thanks very much for watching, and tune in, there's more on the way. All the best. Thank you.